Hello everyone, you're welcome to another episode of Chemistry with Excellence Simplified. Today I'm going to be taking calculation problems in chemistry. There are some calculations that always repeats themselves in chemistry exams, and students battle with them. I already sorted them out with their years so we can do them together. Alright, so the first one here was 2017 JAMB Pass question. It says, how many moles are present in 4.4 grams of CO2? 4.4 grams of CO2. Now, I already placed the solving here, but I'm going to solve them again so you know how it is done step by step. Now, how many moles are present in 4.4 grams of CO2? The first thing anytime you see a equation like this, now check. You can use your pencil to underline on the paper or anything you're solving. How many moles? They're asking you the number of moles present in 4.4 grams of CO2. Now, check what is required here. CO2 is what they're asking for. The first thing you have to find the molar mass of CO2. Anytime you see an equation like this, just find the molar mass of that compound you are giving. And to find the molar mass is very simple. You are given in bracket here C equal to 12, O equal to 16, right? Now, C. The molar mass of CO2, C here is 12, right? So 12 plus O. O is 16, but we have 2 of O here. So you'll be having 16 times 2, right? So the molar mass of CO2 becomes 12 plus 16 times 2 is what? 32. So 12 plus 32 becomes what? 44. 44 grams per mole. Now, you've gotten the molar mass. Now, the molar mass we say is in grams per mole, right? Grams per mole. There's a one shortcut I would have given you there, but let me solve it to the end first before I open your eyes. Now, you are asked to find number of moles. The formula for calculating number of moles is equal to mass over molar mass. That's the formula for calculating number of moles. Number of moles is equal to mass over molar mass. Now, you can see that from the unit. Molar mass is given as, okay, let's get this done first. Now, mass is the mass of we're given is 4.4 grams, right? So 4.4 grams over molar mass. What is the molar mass? We are given the molar mass. We've calculated the molar mass as 44 grams per mole. Right? 44 grams per mole. Now, you will notice from the unit you can get it. Grams will cancel grams, right? If you turn it upside down, you'll be left with moles. So the number of moles here, number of moles is equal to 4.4 divided by 44 will give us what? 0.1 mole. That's the answer to that question. So basically, anytime you're giving something like this, just note the formula. Number of moles is equal to mass over molar mass, right? So since the formula is mass over molar mass, we're giving mass in the equation. You need to calculate the molar mass of the compound. Then you can get it right. So that's option A. That was 2017 JAMB Pass question. Alright, let's see what number 2 is up to. Number 2 is 2015 JAMB Pass question. And the question says, remember I selected only calculation questions. Now, what is the volume occupied by 0.5 mole of a gas at STP? Then you are given 1 mole of a gas is equal to 22.4 dm cube, occupies 22.4 dm cube. Now, this question is actually very, very simple. You are asked, what is the volume? Please always write the parameters given down as quickly as possible. That will open your eyes to what to solve. What is the volume? You're being asked to calculate volume. Occupied by 0.5 mole. We are given the number of moles as 0.5 of a gas at STP. This STP means standard temperature and pressure. Standard temperature and pressure, that's STP. Now, you were given here, in fact this one is already very simple. You are given a hint in bracket that 1 mole of every gas at STP occupies 22.4 dm cube. Sometimes you will not be given. But just know that 1 mole of a gas at STP at standard temperature and pressure occupies 22.4 dm cube. So 1 mole of the gas occupies 22.4 dm cube. Then the question is asking you what volume will be occupied by 0.5 mole. If 1 mole is 22.4 dm cube, 0.5 mole will be how many dn cube? That's what they're asking you. If 1 naira can buy 22 biscuits, 0.5 naira can buy how many? That's just it. So 0.5 moles will be equal to what? Just cross multiply. If you cross multiply, you'll be having 0.5 times 22.4. So 0.5 times 22.4, and that will give us 11.2 dn cube. That's the answer to that question. It's very simple. It's very simple. All right. Moving on to the next question. If you've not subscribed to my channel, click on the subscribe button, else this might be the last video you are seeing from me, because YouTube will not be popping up my video. If you subscribe, what YouTube will do is, once you subscribe, anytime I post a video or I go live, YouTube will just notify you that I've posted a video, so you go and learn. So that's the advantage. It's not that they are charging you. They don't pay. They don't charge you. All right, the next question, 2018 JAMB Pass question. The question says, calculate the empirical formula of a compound containing 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Now, anytime you see a question like this, the first thing you have to do is to smile. Do you know why? It's a bonus question. You are asked to calculate the empirical formula. First of all, what is the empirical formula? Empirical formula is the smallest, the simplest formula of a compound. That simplest formula that you cannot reduce again. Take, for example, let's not talk story. Now, if you look at something like this, C12, C6H12O6. This is the formula for glucose, right? Good. Now, in this formula here, 6 is here, 12 is here, 6 is here. Can we still reduce it? Yes, we can reduce it because 6 is common. 6 can go into 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 here is 1. So CH2O. Among this first one and this second one, which one is the simplest formula? Which one cannot be broken down again? Which one cannot be reduced again? Are you seeing it now? This one here, this second one here that we cannot reduce again, the simplest formula is called the empirical formula. Why this one here that we can still reduce? We still have numbers that can divide themselves in between. It's called the molecular formula. Why the one that we've reduced to the simplest, the simplest is the empirical formula. So anytime you hear empirical formula, don't be afraid. Empirical formula is just the simplest formula. Do you understand? Now, we are asked to calculate the empirical formula of a compound containing 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So, as a chemist you already know that this compound have how many elements? 3, right? Carbon, hydrogen, and oxygen. Just write them out. Carbon, hydrogen, oxygen. You don't want to know. Now, how many percent are we giving? We're giving 40% of carbon. Here we're giving 6.7% hydrogen, and here we're giving 53.3% oxygen. Sometimes what some people setting exam will do is they will tell you it has 3 elements: carbon, hydrogen, and oxygen. They'll give you the percentage of carbon, they'll give you the percentage of hydrogen, then sometimes they will not give you the percentage of oxygen. Just know that the percentage must sum up to 100. That is, this plus this plus this must give you 100. So if they give you only 2 and they didn't give you this one, just do this plus this, then 100 minus anything you have will give you what is supposed to be here. I've opened your eyes though. Alright, so now we have to find the empirical formula. The next thing we have to do, are you saying this is their percentage? This is their percentage abundance. Just divide through by their atomic masses. The mass of carbon is what? 12, right? You divide by 12. Bam. The mass of hydrogen is 1. You divide by hydrogen 1. The mass of oxygen is 16. You divide by 16. Bap. You go your way. 40 divided by 12 will give us what? 3.33, right? Is to 6.1 divided by 1 is what? 6.7. So 6.7 divided by 1 is 6.7. Is to 53.3 divided by 16 is 3.33. At this point, you're almost done. The first thing I did was to write their percentage abundance. After that, I divided by their molar masses, their masses. Then the next thing I'm to do now, are you seeing these values I got after division? You just look for the smallest number among them and divide through by that smallest number. So if you check very well here, what's the smallest number here? The smallest number here is 3.33, right? is 3.33. So I'll just divide everything by the smallest number. 3.33 is smaller than this one now. So 3.33. Yeah, 3.33. So 3.33 divided by 3.33 will give me what? 1 is to. This one divided by this one will give me what? I guess that will be 2 is to. This divided by this is 1. So you can see now that carbon here is just one of it. Hydrogen here is 2 of it. And oxygen is 1 of it. So the empirical formula is CH2O. That's that too. It's very simple as that. Are you seeing it? Very, very simple. Write out the relative, the percentage abundance, the percentage you are given, divide by the molar masses, divide by the smallest number. Go your way. All right, so that's that. Moving on to the next. The next question is JAMB 2012. The question says calculate the pH of 0.001 molar hydrochloric acid. This question, if you see it, just smile too, but let me point out something here. They say calculate the pH, and you know pH is, the formula is minus log hydrogen ion concentration. Please, if you are writing this bracket, you are using this box to show concentration. So pH is equal to minus log hydrogen ion concentration. Now, they say calculate the pH of 0.001 molar, this capital M molar hydrochloric acid. Now, note that hydrochloric acid is a strong acid. If it ionizes, you have hydrogen ion plus chloride ion, right? So you can see that the stoichiometry, what is by the side here, 1 mole of, you can see that 1 mole of HCl will give 1 mole of hydrogen ion. So 1:1. Unlike sulfuric acid that you see, you have 1:2. I pray we'll meet the equation like that so you understand what I'm talking about. Now 1 mole of this, since 1 mole of hydrochloric acid gives 1 mole of hydrogen ion, it means 0.001 molar hydrochloric acid will give 0.001 molar hydrogen ion. So we now know that the concentration of hydrogen ion is 0.001 molar. Now we put it in the formula, pH is equal to minus log. Now the hydrogen concentration now is now 0.001. So minus log 0.001, as a cheat, you don't even need to press your calculator. When you have minus log 0.001, just take the number of zeros you have there. That's your answer. So how many zeros do we have here to the back? 3, right? 3 zeros. Your answer is 3. Do you see how simple it is? Even if it is 0.0000001, count the number of zeros you have. So long as it's ending with 1, count the number of zeros you have. So since we have 0.001, 1, if here is 0.002, you don't count the number of zeros. You use your calculator. JJ 0.001. You have 3 zeros here. Your answer is 3. So our answer here is C. That's 2012. Do you understand? Please, anything you don't understand, drop it in the comment section. I'll respond. And if you've not joined my JAMB, if you are not on my JAMB 2026 group, over 400 persons are already on that group preparing for JAMB 2026. Over 400 persons are already there. So if you're not there yet, my number is on the screen. Chat me up on WhatsApp. I'm going to add you up so you learn, prepare. Alright, but if you're not subscribed, there's no need chatting me up. Click on the subscribe button. Subscribe first. It doesn't bite. And they don't charge you for that. Alright, so moving on to the next question. The next question, what is the oxidation number of nitrogen in nitric acid? Now, the first thing you know is, if you are writing any chemistry exam, JAMB or WAEC, you don't see equation on oxidation number, just check the subject again. It's not chemistry you are writing, it's literature. Return it. You must see equations from this oxidation number, valency and other stuff. You must see it too. What is the oxidation number of nitrogen in hydrogen trioxynitrate 5? This nitric acid here, what is the oxidation number? Now, the good thing about this one is everybody used to understand this one because it's the simplest thing in chemistry. We're given nitric acid, this one here, and we are asked to find the oxidation number of nitrogen, this nitrogen here, the oxidation number. Now, what you are to do, take note of two things. Since it's nitrogen, we are asked to find the oxidation number. We make the value as x, as an unknown x. Then we equate it to the charge on the compound, the overall charge on the compound. Now, there's no charge on this compound, so it's neutral. It becomes 0. Now, hydrogen. What is the oxidation number of hydrogen? Hydrogen is +1. How did I know that? Hydrogen is the first element. So if I'm drawing the share, it's just one electron. So hydrogen will prefer to give out this one. It becomes +1. Except in peroxides, where it becomes -1. Normally, sorry, in hydride, normally it is +1. So the charge on hydrogen, the oxidation number of hydrogen here is +1. Then plus nitrogen is what we are looking for. We'll call it X, plus oxygen. What's the atomic number of oxygen? 8, right? So 8. Let's draw the share configuration. 1, 2, 3, 4, 5, 6, 7, 8. And remember, all elements tend to obtain the octet or duplex configuration. Octet means fill up have 8 electrons in the outermost shell. How many does oxygen have in the outermost shell here? 1, 2, 3, 4, 5, 6. It has 6 in the outermost shell. But for it to be stable, for it to obtain that noble gas configuration, it must have 8 in the outermost shell. So how many does oxygen need to complete, to be balanced in life? It needs just 2 to be balanced. Now, do you think oxygen will be willing to give out these 6 to be balanced, or to beg 2? It will be very easy for oxygen to get 2 than to give out 6, right? So giving is good, begging is bad. So if it is begging, it's negative. If it is giving, it's positive, because the Bible says it is better to give than to receive. It is more blessed to give than to receive. Abi? Maybe so Bible talk. I say talk. So since oxygen is borrowing 2 more to make it balanced, borrowing is bad, so negative, right? How many is it borrowing? 2. So the oxidation number of oxygen is -2. I've explained why it is minus, because it's borrowing, and it's borrowing 2, so -2. But we have 3 of it here in the compound, so -2 times 3. Now, -2 times 3. Now, equal to the overall charge of the compound. If here they written minus or plus or anything, we would have said this compound have charge. But at this point now, there is no charge on the compound. So since there is no charge, we say equal to 0. Do you understand? Now we just solve it as mathematics. 1 plus x minus 2 times 3 is -6 equal to 0, right? Now 1 minus 6 is what? -5, right? So x minus 5 equal to 0. Now, so x is equal to, if this one is crossing, it becomes what? 5. So x is equal to 5. So the oxidation plus 5. Always put your charge when you're calculating the oxidation number. Now, the oxidation number of nitrogen in this compound is 5. That is why if you are calling the IUPAC name of this compound, you say hydrogen trioxonitrate 5. See where the 5 is coming from. The element you are pronouncing last, just calculate the oxidation number. It will tell you what you should call. So hydrogen trioxonitrate. Since I'm calling nitrogen last, I'll calculate the oxidation number, then I add the number there. Hydrogen trioxonitrate 5. That same thing applies to if you have something like H2SO4. This is hydrogen tetraoxosulfate. Sulfate what? Hydrogen tetraoxosulfate. Since I'm calling sulfur last, I'll calculate the oxidation number of sulfur in this compound. Let me quickly do that so you see. But you already know it's 6, right? But let me show you how it is done. So if I have H2SO4, and I'm asked to calculate now H2SO4. I'm asked to calculate the oxidation number of sulfur here. Hydrogen, what's the oxidation number of hydrogen? +1, right? Times 2, because we have 2 of it. Sorry, +1 times 2, because we have 2 of it, plus sulfur is what we are looking for, so we'll call it X, plus oxygen is what? -2, but we have 4 of it, so times 4, equal to the overall charge on the compound is 0. Now you solve your mathematics. 1 times 2 is what? 2 plus x minus 2 times 4 is what? -8 equal to 0. So we'll be having 2 minus x is what? 2 minus 8 is what? So we'll be having x minus 6 equal to 0. So x is equal to what? Plus 6. So the oxidation number of sulfur there is 6. That's why we say hydrogen tetraoxosulfate 6. Do you understand that? Alright, we're going to move on. Moving on to the next one. On to the next. Next question is 2019 past question. How many atoms are present in 3 moles of oxygen gas? How many atoms are present in 3 moles of oxygen gas? Now, this is actually a very simple question. The question says, how many atoms are present in 3 moles of oxygen gas? And they've made the question so simple that in bracket they told you Avogadro is equal to 6.02 times 10 raised to power minus 2. Now check this. I want you to see it with your eyes. See this one with your eyes. Now, 1 mole of any compound contains that Avogadro's number. So 1 mole of oxygen contains 6.02 times 10 raised to power 23 molecules. Now, 3 moles, they're asking you 3 moles. If 1 mole contains this, 3 moles will be what? Just 3 times that number. So you'll be having 3 times the Avogadro's number. So this one now, they are asking you how many. Let's come back to the question here. How many atoms? They didn't ask you how many molecules. Oh. Now, 1 mole, take note because many persons will fail this question. 1 mole of any element, of any particle has Avogadro's number. This particle, this 6.02. So 1 mole of O2, which is the element in question, is a molecule. The molecule has 6.02 times 10 raised to power 23 particles. So 3 moles. So if you calculate this 3 times, this will give us 1.8, right? 1.8 is it? Let me press my calculator. Okay, this one is even better than JAMB calculator. 3 times 6.02. That's, I'll put it 1.806 times 10 raised to power 24. Alright? Now, molecules. So that molecule. But now, one thing you should know is that O2 is a molecule of oxygen. But what you were asked is atoms. O2 contains 2 atoms. 2 atoms of oxygen. 2 atoms of oxygen, because oxygen atom is just like this. So when you put it like this, it means 2 atoms of oxygen, you give you 1 molecule, right? Now, so if this is giving us, if 1 molecule, 3 moles of this is giving us this. Now, we already know that 2 atoms make 1 molecule of oxygen, right? So how do we get the number of atoms? Now we've gotten that this molecule here. Okay, let me take us up. Let me take us up to where we are. So this is where we stopped. Now each molecule has 2 atoms, right? So 1 atom, since each molecule has 2 atoms, we'll be multiplying this times 2, which will give us our answer here. So you just multiply by 2. This 2 is coming from the fact that 1 molecule has 2 atoms. All right. Now, next question. Next question is 2014. Calculate the number of moles of solute in 250 cm cube of 0.1 molar sodium chloride solution. The answer is already here. Calculate the number of moles. The first thing I told you, always underline what you ask to calculate. What you ask to calculate here is number of moles of solute in 250 cm cube. That's the volume of 0.1 molar sodium chloride solution. So we asked to calculate number of moles. Let me call it N. We're given volume as 250 cm cube, and we're given, that's capital letter M, means molar. That is the concentration. So molar concentration is equal to 0.1 molar. 0.1 molar. Now number of moles can be molar concentration times volume. Molar concentration times volume, but the volume is always in liters or dm cube, liters or dm cube. So now you'll be having number of moles will be equal to molar concentration was given as 0.1 times the volume. Volume we're given in cm. To convert it to dm, you divide by 1000, right? 1, 2, 3, divide by 1000. That will give us 0.025. So the answer becomes 0.25. 0.250. 0.250. So 0.1 times 0.250 will give us 0.025 moles. That's the answer to that question, right? Let's move on to the next one. What mass of CaCO3, calcium trioxocarbonate, is required to produce 11.2 dm cube of CO2 at STP? So I want you to look at this question, copy it down and solve it. Copy it down, solve it, and drop the answer in the comment section. What mass of CO2 of calcium trioxocarbonate is required to produce 11.2 dm cube of CO2 at STP? Drop your answer in the comment section. Which subject do you want me to take next? Drop the subject you want me to treat next. Any topic you're having problems with, drop it in the comment section and I'm going to make video on that. If you've not subscribed, click on the subscribe button. Subscribe to my channel. Join my WhatsApp group. Join over 400 persons already on that group chat. Just send me a message on WhatsApp. My WhatsApp number is showing on the screen. So join my WhatsApp group, send me a message, and see you in my next video. My name is Excellence Simplified.